G period AP Calculus, October 18th, 2022. We good? We'll go ahead and screen mirror. See how far we can get. So we finished on this example 3 problem. Right, we were talking about derivatives in context. Derivatives in context, right? So here we found that w prime of 20 is equal to negative 0.286. How do we interpret it? Well, we got to look at this. W prime, right, that's going to be the slope. So the slope, my independent variable here, right, my original function is called w of v. Notice that it's called w of v, okay? So w prime in general, the meaning of that is going to be delta w, or change in w over my change in v. What does w represent? It represents wind chill, so change in wind chill. Change in wind chill. That's in degrees Fahrenheit. You need to have your units over change in wind velocity. That's miles per hour. We all following me so far, right? I just wrote down. I just thought about, okay, the first derivative means the slope, right? And then slope is change in my dependent variable or my vertical axis variable over my independent variable or my horizontal axis variable, okay? What is my W? What is my V? W is wind chill in degrees Fahrenheit. V is wind velocity in miles per hour, okay? So we know in general the first derivative means change in wind chill over in degrees Fahrenheit over change in wind velocity miles per hour. And then let's look at the actual, like what it means for W prime of 20 to equal negative 0.286. What that means is the slope of this function at that point, at x equals 20, is negative 0.286. So when, right, this is v equals 20, when v is 20, or when the wind velocity is 20 miles per hour, the wind chill's decreasing, right, it's going down, negative slope, at a rate of 0.286 degrees Fahrenheit for every 1 mile per increase in the wind velocity, okay? How we feel about that? Kind of a long problem, kind of a lot to process, but it's pretty formulaic once you get the hang of it. Where it came from? Yeah, so we got it, we just took, so we have W of V here. They give us W of V right here, and then what we did was we used our calculators. Yeah, we used our calculators to...
you just derive what they gave you and then plug it in 20?
Yeah, but you're going to do that with your calculator. So if you have your... so on here, let's do it with calculator before. Right, it was math and derive, and then my function was what?
Come on, let's be reasonable.
55.6 minus 22.1x to the 0.16. And we want to evaluate that at x equals 20, right? That's where that came from, okay? That's where that came from. So.
When you wrote it, it says like is W prime just like the notation?
W prime is just the notation. That means, yeah, 20, v equals 20 plugged into the first derivative function, okay? Let's move on then in the notes, okay? All right, 4.2. Was there a 4.1 homework or no?
No.
Okay. Wait, I have one.
I know. We were not given it.
All right, you'll be given it now, okay? I'll make sure to upload this to the school dude. Let's make this due like after the test, though. Are you okay with that? It's a little too much.
Yeah.
You guys already have a lot on your plate. Oh, this is the one I accidentally stapled wrong. All right, sorry. Some men just want to watch the world burn. Hey, we gotta appreciate it. Some cultures, that's how they staple. Okay. Inclusiveness and diversity.
Wait, this is not true.
This is how they staple in like Germany. This is how they staple. Yeah,
Fact check that.
we should fact check that. Carrie used to live in Germany. She would know.
This should be a crime.
Oh, it's actually nicer.
Really?
I like it.
Yeah.
Never mind.
All right, so I'll make that due like Wednesday or Thursday
I
next
was
week.
about to say, I don't know.
All right, let's move on to 4.2.
You could have stapled it right here.
In the dead center. All right, now let's revisit an idea that was introduced during topic 3.6. When we study motion, initiating calculus, we consider what's referred to as straight line motion. When we study this idea, we're concerned with four concepts: position, velocity, speed, and acceleration. Okay. Position. Okay, so what's going on here is we're going to study basically what's called one-dimensional motion. So like the motion of an object that's kind of like confined to a track, if that makes any sense, right? Think of like a train. It can only move in two different directions. There will be one direction which we define as the positive x direction, and one direction which we define as the negative x direction. Okay, we feeling so far? Okay. So we're not. We got to learn how to do all this and how to do calculus in one variable before we can learn how to do it in many variables. So for Calc 1, we're just going to stick to one-dimensional motion. Okay, we're not going to do like a car moving around like a track, or an airplane or a helicopter moving around. Okay, we're just going to deal with just one dimension. Okay. So let's say there's a particle moving along the x-axis. Okay. All right, it's moving along the x-axis and its position, right? Let's call this x of t. X of t is equal to t squared minus 2t minus 3, okay? All right, so what it's asking for is like, what is its position on the number line when t is 0? What would that be? Negative 3. So this would be x of 0. What about when t equals 1? It would be 1 squared minus 2 minus 3. So what's that? 1 minus 2 minus 3, was that negative 4?
Yeah.
Okay, correct me if I'm wrong. When t is 2, it's going to be 4 minus 3, so negative 3 again. All right, when it's 3, we have 9 minus 6 minus 3, so that's 0. When it's 4, we're going to have 16 minus 8, which is 8 minus 3, which is 5. Okay, and I don't know if you guys kind of like picked up on this. What happens is particle starts here, starts moving backward, then it stops, slows down, stops, turns around, comes back. Can we see that? X of 0, x of 1, x of 2, 3, 4. Did I skip 4? Oh, that is 4. Sorry. My bad. I'm sorry. Okay. Yeah. So then we're gonna that brings into question the concept of velocity. Okay. Velocity function v of t is the change of the position function over time. So if we're using s or x, so v of t is going to be equal to x prime of t. Right, velocity is the change in position at a given instant. It's the change in position at a given instant. Okay. Right, so here, right, for this example, okay, right, so like when the particle was traveling back to the right, its position was negative, right? It was to the left of the it was to the left of x equals 0, right? But its velocity was positive because its position was increasing. Okay. Okay. All right. So here's how to interpret that. Okay. V of t, object moves to the right. V of t less than negative, that means the object is moving to the left. V of t equals 0 means the object has stopped. It is not moving. Its position is not changing. Okay. Or if we're talking about like vertical motion, up and down. Okay. So a lot of you guys in physics, you do a lot of high school physics problems are just like one-dimensional up and down motion, like a ball. Right. Yeah. All right. You want to talk about? Let's talk about acceleration now. Okay, acceleration is going to be change in velocity, or the rate, the change, right? Velocity is the change in position. So a of t is going to be v prime of t, which is also x double prime of t. On your cars, you have two devices that change your velocity. They change your rate of change, right? What are they? brake and the gas, yeah. Yeah, the brake and the gas. So, yeah. Seat warmer. Seat warmer actually technically slows you down. Actually, I have a funny story. So there was when I was back in religious life, we had a guy in our novitiate class who was like big guy, like 400 pounds, and we were driving to Massachusetts, and like every time he was in the driver's seat, like we had like the automatic seats, and every time he like was it forward or back, like every time like he pushed himself forward or back, like the recoil would like slow the car. The engine would like rev up. Like he was putting himself back, and you just feel like the RPMs like increase. So I guess for some people, the like seat position adjuster would also, if you're big enough. That's some good physics right there. Hey, every action has an equal and opposite reaction. You know? Anyway, so yeah. Let's take a look at this table, right? A of t equals 0 means the velocity is not changing. Okay. A of t means less than 0 means our velocity is getting smaller, it's getting more negative. Greater than 0 means our velocity is getting more positive. Right? Just because an object's acceleration is 0 does not mean that the object is stopped. Okay, so if an object's like traveling at a constant velocity, its acceleration is 0, but it's not at rest, right? So if you like took a baseball and you were like at the International Space Station, you took a baseball and you just like threw it out into space, right? Its acceleration would be, well,
It's like not true.
yeah, it's not true. Let's say like you're like in interstellar space. Let's say in your interstellar space, you take a baseball and you throw it. The baseball's just going to keep traveling in a straight line forever. So it's not at rest, but its acceleration is 0. Okay. International Space Station is a little different because you're still like within Earth's gravity. Anyway, what device in your car will keep the car's acceleration equal to 0? Here's a good one. Cruise control. Yeah, cruise control. Being a good driver. A steady foot. Steady hand, bro. Also, just because you have a positive acceleration doesn't mean you're moving to the right. That makes sense, actually. Right? So in this example, right, we were traveling to the left, right? Our particle started here. It was traveling to the left to get to x of 1. But as it was doing that, it was starting to slow down. Its velocity was slowing down. It was starting to turn around, which means as it was moving to the left here, our velocity was negative, but the acceleration was positive. If that makes any sense. Slowing down, when you're traveling in the negative direction and you start slowing down, that means your acceleration is positive because your velocity is getting less negative. All right. So.
Wait, what?
So acceleration, strictly speaking, if your acceleration, you're right. So you can have like your v of t, your velocity can be less than 0 with your acceleration being greater than 0. That's what I'm saying. So like here, right, our particle was traveling to the left, right? It had a negative velocity, but the velocity was like getting less negative. It was like still negative, but it was getting closer and closer to 0 till this point when the velocity was equal to 0, and then it actually became positive and started moving.
So decelerating is not negative acceleration.
Decelerating, no. In this, no, it's not. Yeah,
It's just less
not
than
necessarily. Yeah, if you're traveling in the negative x direction, you decelerate. Your acceleration is positive because your velocity is increasing.
Okay.
All right. Yeah. Yes. So for instance, suppose you were walking to the right when all of a sudden a large wind started to blow to the left. What would occur? You would start to slow down, and if the wind was too large, you would go in the negative. Next direction. Let's do the second example. Particle moves along the x-axis with position function s of t equals t squared minus 4t plus 2. What's my velocity then? What's that equal to? Yeah, s prime of t. So that's 2t minus 4. what's my acceleration equal to? Yeah, b prime of t or s double prime of t equals 2. Okay. So complete the chart for the first 5 seconds and show where the particle is on the number line. Okay. So s sub t, right? When s sub t is, let's talk about s sub t then. Okay, so when t is 0, s sub t is 2, right? When t is 1, it's 1 minus 4, which is negative 3 plus 2, so it's negative 1. When it's 2, when t equals 2, it's, correct me if I get any of these wrong, 4 minus 8 plus 2, which is negative 2, right? Or no? When it's
Yes.
plus 2? Okay.
It's negative 2.
All right, 3, 9 minus 12 plus 2. 9 minus, right? Did I do that wrong? 9 minus 12 plus 2, which is negative 1, right? And then 4, 16 minus 16 plus 2, positive 2. Whoops. And then 5, it's going to be 25 minus 20 plus 2, which is 7. Okay, so for v of t, right, that's just a linear function. Okay, so when t equals 0, my velocity is negative 4, and then it's just going to go up by 2 each time, right? Increases by 2 each time t increases by 1. And then the absolute value of v of t is going to be 4, 2, and then 0, 2, 4, 6. The absolute value of my velocity is what's known as speed. Speed does not take our direction into account. It doesn't take the direction that we're traveling in, i.e., in other words, it does not take the sign of the velocity into account. Or it's the absolute value of the velocity. And then acceleration is just 2. Description. So right here it's right positive position. Are we traveling to the left or the right? Left is the negative direction, right is the positive direction. So are we traveling left or right? Yeah, we're traveling left. Why is that, Brooke? Yeah, so my velocity is negative, so we're traveling in the negative direction. But what's happening to our velocity? Is our velocity, is it increasing or decreasing? It's increasing. Why is it increasing, Ava? Yeah. So just looking at the chart, you can tell exactly. Yeah, it's always going to be increasing because my acceleration is always positive. Okay. So, all right. So this next one, negative position. Are we traveling to the left or right? Left. Yep. And then velocity is increasing. We're traveling left, but we're going to the left like a little more slowly now, right? We're hitting the brakes, and then velocity is increasing. And then let's just talk about t equals 2. Right, negative position still. Our velocity, now we're at rest, right? We're at rest, so we're stopped, like we were slowing down, we stopped, and then we're going to turn around is basically what's happening. So we're at rest, and we're at rest, but our speed's still increasing. It's switching from negative to positive at this point. Does that make sense? No sense? Yeah. So for t equals 2 right here, right, our velocity is still increasing because acceleration is positive, but our velocity is equal to 0. So it's equal to 0, but it's like passing through 0, if that makes any sense. So it's going from a negative number to positive numbers. It's passing through 0, so it's at rest, right? We hit the brakes, we're right at that instant where we stopped, and then we're putting it in reverse, and we're going back in that positive direction, okay? And then right at 3, position's still negative. My velocity's positive, and it's getting bigger, right? So we're speeding up again. And then at 4, we're finally in the positive region. Velocity still getting more positive. Okay, we're traveling in the positive direction faster and faster. Okay. So like this board where the number line, right? We started walking really fast here, and then we slowed down, right? We stopped, and then we backed up faster and faster and faster.
Wait, is 3 in the negative or positive position?
3 is in the negative, right?
Oh, yeah.
Okay. And then relationship between velocity and acceleration. Yeah, so what does it mean then? So this is a good chart. If both, let's look at this, fill out this chart, okay? If both the acceleration and the velocity are greater than 0, is our particle speeding up or slowing down, or is it at constant, speed or stopped? So v greater than 0, does that mean we're moving in the positive direction? Okay, yeah, it means we're moving in the positive direction. A greater than 0, does that mean our velocity is getting more positive or more negative or what? More positive, so we're speeding up. Okay, it's speeding up. Does that make any sense? We're moving in the positive direction ever faster. Okay. What about when acceleration is greater than 0, right? And our velocity is less than 0. So velocity is less than 0 means we're moving to the left, we're moving in the negative direction. But what's happening? Are we slowing down or speeding up? We're moving in the negative direction. If we're speeding up, that means we're getting, our velocity is getting even more negative, right?
Slowing down.
So we're going to be slowing down. Right, if we're moving in the negative direction, but our acceleration is positive, that means our velocity is getting less negative, if that makes any sense. Okay, and then if v equals 0, if our velocity equals 0, so we're at rest. Yeah, so the parking, so velocity is equal to 0, but acceleration is great. I'm pretty sure this is speeding. Let me check. Okay, so it stopped from when v is equal to 0, it stopped. That makes sense. Right, when velocity is equal to 0, that means our position's not changing at all, so we're stopped. Okay, and when acceleration's 0, right, this third column here, when our acceleration is 0, and if our acceleration is 0 and we're not at rest, that means we're moving at a constant speed. So if your acceleration is 0, you're either at rest or moving at constant speed. Okay. If your velocity is 0, that means your position is not changing at all, so you're stopped. And then these other two lines, if our acceleration is less than 0 and our velocity is greater than 0, are we speeding up or slowing down? Slowing down. Why are we slowing down? Right, so our acceleration so we're moving it, what's going on is we're moving in the positive direction since v is greater than 0, but that velocity is decreasing, right, because acceleration is negative, so we're slowing down. And then what about v less than 0 and acceleration less than 0? Is that speeding up or slowing down? Speeding up, yeah. So there's a difference between speed and velocity. What? Speed, yeah, so speed doesn't take direction into account, velocity does. Did you guys learn vectors last year in calculus?
No, I don't.
No?
Yeah.
Yeah, so speed is the magnitude of the velocity vector. Negative direction means to the left. Well, it's whatever we define as the negative direction, but if you're looking at a number line, think of it as like moving to the left. Okay. How are we feeling about this? Example 3, let's determine intervals where particles are slowing down and speeding up. We can make a sign chart for velocity, a sign chart for acceleration, and a third sign chart, which is the product of the first two, okay? So notice here on this chart here, right, they were slowing down when the signs were opposite, so slowing down meant, so where should I write this? Right, note. slowing down when v of t and a of t have opposite signs. Right, and we were speeding up when they have the same sign. Okay. So for example 3, determine, let's get this written down real quick actually. You guys ready to do example A? Okay. So for example A, I'm going to erase this real quick, okay? So for example A, so let's figure out what the velocity function is. Right, it's going to be s prime of t. It's going to be equal to 2t minus 6, okay? Acceleration is going to be s double prime or v prime. It's going to be equal to 2, okay? So they said make a sign chart. So let's make a sign chart for velocity. So here's t, here's v of t, okay? The 0, this function is equal to 0 where? T equals 3. And it has a positive slope, so it's negative here and positive here, okay? And then our acceleration is just positive everywhere, okay? So from negative infinity, from t equals negative infinity to 3, our velocity is going to have a negative sign, and our acceleration is going to have a positive sign, so it's going to be speeding up on this interval, negative infinity to 3. I mean, sorry, slowing down, right? Sorry, slowing down. And then from 3 to infinity, positive 3 to positive infinity, right, our velocity has a positive sign, and our acceleration has a positive sign. Because the signs are the same, we're going to be speeding up, okay? Does that make any sense? So velocity and acceleration having opposite signs means the particle's slowing down. If they have the same sign, that means the particle's speeding up, okay? So what we did here was we made, we calculated the velocity function. We saw what intervals it was negative on and which intervals it was positive on, okay? Because it's a line, it's just traveling positive slope through this 0 right here, okay? And then acceleration is just positive everywhere, okay? So that's how we know the intervals where it's speeding up and slowing down. Does that make any sense?
Wait, so how did you get to the 3?
3 is going to be, okay, look at this v of t here. Where is v of t equal to 0? It's equal to 0 when t equals 3. So 6 minus 6, right? 2 times 3 minus 6 is 6 minus 6, which equals 0. So we know that this, if we graph the velocity function, it's going to be a line right here.
Why is the acceleration always positive?
Acceleration is always positive because when we take the second derivative of s, we get positive 2. It's constant. So like Earth, like gravity has constant acceleration. Okay. Can you guys do this for B? V of t equals 3t squared minus 6t. I'm going to factor that to make it easier to graph. So t times 3t minus 6. Okay. And then a of t is going to be the derivative of my velocity, which is going to be 6t minus 6. Okay, so let's graph both of these. Okay, I'll color code these to make it a little easier to read. Let's do this in red. Let's do this other one in blue. So let's graph the velocity in red. Okay. So the zeros, this is going to be an upward opening parabola. So 0 here. The other 0 is going to be what? 2. T equals 2. This is t equals 0. And t equals 2. Okay. Okay. It's going to be upward facing. It's going to be so if you think about it, it's going to be like an upward opening parabola, like that. Okay. So here to the left of 0, velocity is going to be positive. Between 0 and 2, velocity is going to be negative, and then to the right of t equals 2, it's going to be positive again. Okay, so we just graphed that parabola, basically. Are we following so far? So to the left, do you see like why the parabola is the way it is? Okay, so to the left of t equals 0, my parabola is above the horizontal axis. Between them, it's below, and to the right, it's above the horizontal axis again. Okay. All right, so. Okay, and then let's graph the acceleration in blue, t and a of t. Okay, so that has a 0 at t equals 1. So here at t equals 1, right, and it has a positive slope. So it's going to be a line that looks something like this. It doesn't need to be perfect, right, because we're just trying to determine the sign, right? And so to the left of t equals 1, our acceleration is going to be negative, and to the right of it, it's going to be positive, okay? So now we got to determine the intervals, right? We're going to have transitions, so from negative infinity to t equals 0. So from t equals negative infinity to 0, it's going to be doing what? Speeding up or slowing down? So let's look at this. Look at our red graph, right? When our red and blue have opposite signs, the particle's slowing down. When they have the same sign, it's speeding up. So from negative infinity to 0, velocity's positive, acceleration's negative. So what's it doing? Slowing down, yeah. And then our next transition is going to come t equals 0. Our next interval is going to be t equals 0 to t equals 1. So what's it doing there?
Wait, how do you know how it's
Which one do you use? Is it the name?
So from t equals 0 to t equals 1, I'm going to plot that in blue here. Is our velocity negative or positive? And is our acceleration negative or positive? So it's going to be doing what? Speeding up, right?
How do you know to do the next one at 1?
I'm going from, so I'm taking all the zeros. So the two zeros of my parabola are t equals 0 and t equals 2. And the 1 0 of my line is t equals 1. So I'm going from negative infinity to the first 0 to the second 0 to the third 0 to positive infinity. Does that make any sense? Yeah, so there's going to be another one. Another interval is going to be 1 to 2.
With both of them?
It's speeding up because the on 0 to 1 because the velocity is negative, and the acceleration is also negative. And when they have the same sign, the particles speed up. To the left of t equals 1, my line is negative. My line's below the horizontal axis. You see that? Yeah.
Wouldn't it when t equals 1 be 0?
When it does, yeah. So it's at rest. It's not at rest. It's constant speed at t equals 1. So it's yeah. Notice I'm using parentheses here. I'm not looking at the actual zeros. It's going to be at rest at these two, at t equals 0 and t equals 2, and it's going to be constant speed at t equals 1. Okay, so from the interval from 1 to 2, am I going to be speeding up or slowing down? Slowing down, right? So on this interval here, we look at this graph, 1 to 2, right? My parabola is below the horizontal axis, so my velocity is negative. Over here, from anywhere to the right of t equals 1, my acceleration is positive. So they have opposite signs, so the particle is going to be slowing down. Okay. And then from 2 to infinity, 2 to positive infinity. Speeding up. Yeah, they're both going to be positive. Yeah, so the direction said determine when it's slowing down or speeding up. So we don't include the zeros themselves because it's either going to be at rest or constant speed at the zeros, right? When anywhere velocity is equal to 0, it's at rest. Anywhere acceleration is equal to 0, it's going to be traveling at a constant speed. How you feeling about that? Did you follow? Maybe you couldn't have done it on your own, but did you follow? That's good. I love sign charts. Okay, on the AP exam, okay, this is good to write. Let's read through this. Okay, so when they ask you a problem on the AP exam or on a test, what does it say? It says sign charts are not scored as justifications by the readers. Instead, the reader's looking for an answer in sentence form. So students are encouraged to make a sign chart, but your sign chart can't be your final answer because it's not up to your reader, to your grader to interpret your sign chart for you. It's up to you to actually, when you're doing a word problem like this, give your answer in the context of the problem. So, yeah, that makes sense. So for example, for particles moving along a horizontal line with this function s given by this cubic polynomial, do an analysis of the particle's direction, acceleration, motion, and position. Okay, so right, we'll make a sign chart here. Okay, so s position is s. Ooh. So make a sign chart for the position. Do you get a calculator here or no? Answer D does. See if they use the rational roots theorem. How much more of 4.2 do we have? Okay, we got a good amount. Let's go ahead. Yeah, let's go ahead and save this for next time. We'll finish 4.2 next time and start 4.3. How you guys feeling about this? Yeah, it's very physics. Yep. I always like to use examples of particles. Remember, guys, this is only for particles that aren't moving too close to the speed of light. When they get close to the speed of light, things change.
Oh, yeah.
What's that?
Everything changes when we're close to speed.
Yeah. Don't worry about what I just said.
I actually,
Being a physics snob. Oh, wait, have you anything for fun for